Alright, so I wanted to make a short video just going over a couple of tips when memorizing the exact trigonometric values for a 30-degree angle, a 45-degree angle, or a 60-degree angle. Alright, so this flashes us back to geometry with these two special right triangles. On the left here we have a 30, 60, 90 right triangle, and on the right we have a 45, 45, 90 right triangle. So these were some of the values that we had to memorize when we were working with trig and triangles back in geometry. So there's going to be relationships. If I talk about the sine of 30 degrees, that would be opposite over hypotenuse. So that would be x over, so sine of 30 degrees here, SOHCAHTOA, is x over 2x, which the x's cancel out here, and that becomes 1/2. Now that holds the exact same ratio as the cosine of 60 degrees here. Whoops, alright, so the cosine of 60 degrees, if I'm looking at 60 degrees, cosine is adjacent. Cosine of 60 degrees is adjacent over hypotenuse, or x over 2x, which is 1/2. So you're going to see with, sine and cosine, there's going to be relationships with these complementary angles. Alright, and there's going to be interesting relationships with a 45, 45, 90 right triangle, since two of these sides are the exact same. So if I go back to my chart here, I right away know some of these values. So the sine of 30 degrees, that's one that I have memorized right off the bat. Sine of 30 degrees is 1/2, which makes the cosine of 60 degrees 1/2. I always have my table arranged like this so that, I'm placing them in opposite spots here. And then the cosine of 30 degrees, I just need to memorize it, is radical 3 over 2, which makes the sine of 60 degrees radical 3 over 2. Now the sine and the cosine for 45 degrees is going to be the exact same, because it doesn't matter whether I am taking, the side opposite over the hypotenuse or the side adjacent over the hypotenuse, because those opposite and adjacent sides are the exact same in measure. Alright, so they're both radical 2 over 2. And in order to get tangent from those, so these are the only two columns I really need to memorize. In order to get tangent, all you need to do is the sine divided by the cosine. Alright, so if you don't straightforward memorize this column, that's okay. You can compute it if you know that tangent is sine over cosine. Sine of theta over cosine of theta. Alright, so I could take that 1/2, and then when I divide it by radical 3 over 2, I keep my 1/2, and I switch what I'm doing, so I go to multiply, and I then flip my fraction here, so the 2's cancel out. It's 1 over radical 3, which I can't write it like that, so that is truly my answer, but I can't write it like that. I rationalize the denominator, so it becomes radical 3 over 3. And then I do the same process, sine divided by cosine. Well, radical 2 over 2 divided by radical 2 over 2. Sine divided by cosine, that's going to give me 1. They're the exact same values, so when I divide them, it's going to give me the value of 1. And then when I do radical 3 over 2 divided by 1/2, that's going to give me radical 3. Right? Feel free to compute those values. And then from there, all I need to do is take the reciprocal in order to get cosecant. So I'm going to take sine, take the reciprocal, and in order to get cosecant. So take 1/2, flip it, and that becomes 2 over 1, or 2. And then this becomes 2 over radical 3, so I need to rationalize my denominator here. So this becomes 2 radical 3 over 3. And if you remember the relationships with sine and cosine, it's going to be the same sort of relationship between cosecant and secant when we're messing with those complementary angles here. So a 2 is going to appear down here. A 2 radical 3 over 3 is going to appear in the top right for secant of 30 degrees. And then when I take my reciprocal of 2 over radical 2 for the 45 degree angles here, I need to rationalize my denominator, and I get 2 radical 2 over 4, or sorry, 2 radical 2 over square root of 4, which is 2, and those 2's cancel out. So when I rationalize the denominator, if you think about it, we need to never have those square roots in the denominator. Alright, so I had to rationalize my denominator for these terms here. And so sometimes when you rationalize the denominator of the reciprocal, those square roots are going to drop out, and overall you're not going to see a fraction. So just keep in mind, you might feel like you're doing something wrong, but you're not. Alright, and then in order to find secant, it's going to be the exact same for 45. It's going to be radical 2. And then I'm going to go through this same process, taking the reciprocal of the tangent in order to get the cotangent. So 3 over radical 3 over 3. If I look back at the work I did to get there, I had 1 over radical 3 before I rationalized it. So that gives me radical 3 over 1, or just radical 3. And then when I take the reciprocal of 1 over 1, 1. And then when I take the reciprocal of radical 3, which it's currently over 1, it becomes 1 over radical 3, which I need to rationalize, which becomes radical 3 over 3. So there is a good amount of work to be shown just with, keeping your fractions, flipping them, rationalizing your denominator. But the good news is that if you are to memorize these values, especially when you're moving on to pre-cal, all you need to memorize are these first 2 rows here. Alright, because you should be able to produce all of the other values if you just have those first 2 columns. Alright, if you guys have any other questions, feel free to ask.